Okay, this video is just kind of a refresher video on finding relative mins and maxes and absolute mins and maxes. So let me cover all of this stuff up first. And I'm going to go ahead and freeze this screen so I actually can write down here if I need to. So remember when we find mins and maxes, relative mins and relative maxes are these things. Absolute mins and maxes on a certain domain. Well, maybe the domain is from here to here. Well, this would be the maximum point. That would be the absolute max. But this right here would be a relative max. Well, and if this point right here happens to be the same height as that, well, whatever that height is would be both a relative min and an absolute min. And this point right here would also be an absolute min. So when we're talking about absolute, you have to consider the endpoints. When you look at this x right here and this x right here, what is the height of the y's? And then you also have to check the relative mins and maxes by checking the first derivative. All right. So for relative mins and max, you take the I froze it, so now I can't move it. All right. So you take the derivative. So y prime is equal to 3x cubed minus 8x. Well, these both have let's see, 3x squared is the derivative minus 8x. Well, they both have an x in common, and I'm going to set this equal to 0, factor out an x, and that leaves 3x, subtract 8. Well, this x will equal 0, and this x will equal positive 8/3. Well, so you're going to say f of 0 is equal, and then you're going to do this. Well, in here, let's do this. And then f of 8/3 will give you a value. All right, so this is f of 0. This is f of 8/3. In the parentheses, putting coordinate points. So you could do this curve sketching method, but we really don't even need to do that. We know that the first derivative produces, and if this is the graph of a cubic, then this is the 0, and this right here is 8/3. This will be the relative max. This will be the relative min. You just need to find the exact point that will be. That's why I put it in the parentheses showing the coordinate point. So when you plug f of 0, this is back into the original function. F of 0, you get a height of 7. So this relative max right here is at the point 0, 7. And then when you plug 8/3, so let's see, 8 parentheses, 8 fraction 3 parentheses caret 3 for cubed minus 4 parentheses 8 fraction button 3 parentheses squared plus 7, you get this mixed number. So I'm going to hit second, the ABC button, and that gives me negative 67/27. Just like that. So this relative min down there is 8/3 negative 67/27. And if I said, hey, not only find those points, but draw a sketch, this is what I would be talking about. That you would be able to show me the basic parent graph of a cubic, and then be able to tell by the information you have here the mins and maxes. Okay, so now we're going to talk about absolute. So I'm going to move this up here. And now I can write over there that without freezing it. So for absolute, you have to do endpoints too. So you're going to, one of the first things that you're going to do is just plug in f of 4. So when you plug f of 4 into all of that, you get a height of 0. And then f of -1, -1 will go into that entire function, and you get a height of 6. Well, we don't know, so these are at the endpoints of the domain, right? So this is an x cubed. So wherever that is, these are the endpoints. Well, now we have to find relative mins and maxes. So these will be the relative. So we take the derivative of the original function. So 3x squared plus 16x plus 21. Now we're going to factor that. So since 3 is prime, 3x plus something times, in the second set of parentheses, x plus something, and I'll put blanks under the something. Well, now you're going to have to do factors of 21 will go into blanks, but remember it'll be 3 times one of the factors plus this x times one of the factors, and they have to add up to 16x. So let's see what I did down here. Oh, I just left x is equal, x is equal. So if I put 3 there, that means 7 would go here. And look at what we have. 3x times 3 is 9x. 7 times x is 7x. When you add those together, you get 16x. So those are our factors. And so you do the additive inverses. So, and then, or the inverse operation. So x is equal, the opposite to positive 7 is negative 7. And the inverse of multiplying 3 is dividing 3. So at -7/3 will either be a min or a max. And then where x is equal to -3, because the opposite of positive 3 is -3, well, you're going to plug -3 and -7/3 into the original. And so I did that. I did f of -3 and f of, ooh, yikes. So my guess is I plugged in positive 7/3 instead of -7/3. So I'm actually going to cross that out. Okay, got that corrected. So now look at, you can draw the diagram, but you can actually look at these values and which one's the highest value? Well, 50 divides 7 is a little bit bigger than 7, right? 7 1/7, well, that's the highest value. So that is going to be not only an absolute min, so you would say where x is equal to -7/3, that's both an absolute and a relative, max, because it's the high value, right? -7/3, and that makes sense. -7/3 would be here, right? So it's a relative max, but also an absolute max. Okay, although this drawing right there probably is not going to depict that very well. And then what's our lowest point? Where our lowest point is 0. So where x is equal to -4, that will be our absolute min. Now, was it asking for the relative max? No. I just wanted to point out that because we found the -7/3 through the first derivative, that is a relative min. It just so happens that that's on that domain that also was. So let's see. Let's draw this again. So let's say the domain is from here to here. Well, that is the tallest point. That also happens to be a relative max. So that is an absolute and relative max. And then 0 is our absolute min. All right, that's it for a refresher on relative and absolute mins and maxes.